Hello, welcome to Chris Khan Academy, the YouTube channel which brings you about mathematics and biology. Now we want to discuss about mathematics on the point called linear algebra. Uh, in linear algebra, it is where we find what we call matrilinear algebra. This is where we are looking to use one of the example which explains more about linear algebra, which states that we have the question: find an orthogonal basis spanned by a set of vector as well as the orthonormal basis. We are going to find the orthogonal basis spanned by a set of vector and also as well as the orthonormal basis. We have a good example. There is a appropriate matrix given where we have x1 and x2 with a set of numbers which has 2, -5 and 1. This is x1, and x2 is 4, -1 and 2. This is a good example. We're going to find an orthogonal basis spanned by a set of vector as well as its orthonormal basis. So let us go ahead. Spanned by a set of vectors x1 which is equal to 2, -5 and 1, and also x2 which is equal to 4, -1 and 2. So here we are going to use Schmidt's method to find the respective orthonormal basis which is spanned by this x1 and x2. I think we have to make a recall on the formulas used to calculate the Gram-Schmidt's in appropriate given vectors. Here we know that v1 of Gram-Schmidt is equal to x1, and x2 and v2 is equal to x2 minus projection of v1 times x2. This is equal to x2 minus x2 v1 times v1 divided by v1 transpose times v1. So here Gram-Schmidt expresses, as I said, v1 equal to x1 and v2 is equal to x2 minus projection of v1 then times x2 which is equal to x2 minus x2 v1 times v1, so divided by v2 v1 times v1 in projection or the inverse over the v1. This is the formula of calculating what we call v2 in Schmidt method. Everybody have to make a note on this formula to understand better, such that any question you have given about Schmidt's method, v2 and v1, it is very easy to calculate or to work out what we call an appropriate question given to Schmidt. So means that v2 is equal to x2 minus x2 transpose v1 divided in general v1. So we have another one. How can work out to v3? v3 we work out it by x3 minus projection v1 x3 then minus projection of v2 x3, and we know the projection of v1 and v2 we have it. So v3 is equal to x3 minus x3 v1 over v1 projection, v1 transpose v1 then times v1 then minus x3 transpose times v2 divided by v2 transpose times v2 not transposed then general times v2. This is how we calculate v3 in appropriate word, in appropriate given matrix. So as I said, this is equal to x3 minus projection of v1 then minus projection of v2 times x3 so this is x3 minus v1 x3 v1 divided by v1 transpose times v1 also in general times v1. So minus again x3 transpose divided by v1 v2 transpose v2 then times v2. This is the formula of calculate. In this video I would like to summarize to show you how we formulate Schmidt's method. By any time given variables of x1 and variables of x2, you can be ready to work out your question with these provided formulas. So we have to work out or to go back to video will explaining more about that question that you written and how you can solve that question using this formula that we formulated in the Schmidt. Thank you.